I welcome you to my YouTube channel. In this video, I am going to teach you how you can balance redox reaction. Let us start our discussion. The principle that we are going to use here is to make the number of units of oxidation equal to the number of units of reduction. We have two different methods to balance this. First one, ion electron method, or it can be called as half reaction method. The second method is oxidation number method. So today I'm going to teach how you can balance any redox reaction using ion electron method. I'm going to tell you the steps involved. The first step is to write unbalanced equation in ionic form. So this is the first important step you need to do. The second step is to divide the equation two halves. What do you mean by two halves? One is which substance undergoing oxidation and which substance undergoing reduction. So these are the two halves you need to find out. Then the next one, you need to balance each half reaction, oxidation half reaction and reduction half reaction separately. Balance other atoms other than oxygen and hydrogen. Got it? The next step is to balance oxygen. For that, what you need to do, we are going to add required number of water. Got it? So when you introduce water, so you are introducing hydrogen. So to balance the hydrogen atom in acidic medium, you are going to add H plus on the opposite side. Got it? The next one, if you are using basic medium, you are adding water on the side where you have deficient number of hydrogen, and so you will be adding equal number of OH minus on the opposite side. So this is the difference. If you carry out the reaction in acidic medium, you will be adding water to balance oxygen, and then to balance hydrogen you will be adding H plus on the opposite side. But if you carry out the reaction in basic medium, you will be adding water, right? And on the side where you will be adding this water molecule, on the side where you have the less hydrogen atom, and then you will be adding equal number of OH minus on the opposite side. Then what we do is we will be balancing the charge by adding electrons. Got it? Then you need to equalize the number of electrons. So the number of electron lost should be equal to number of electron gained. If not, what you need to do is you will be choosing a certain integers to multiply the half reaction to make the number of electron lost equal with the number of electron gain. Got it? Then the last step is to add those half reactions to obtain overall balanced equation. Clear? Then you can simply verify whether the equation is balanced or not. We will be seeing one example. Now I'm going to balance this equation. First step, we need to write it in ionic form. Next step is to find out which substance undergoing oxidation, which substance undergoing reduction. Here, what are the elements are there? Let us see. We have Cr, we have O, we have S, and then we have O here. On the right hand side, we have Cr, S, and O. So we have three different types. Cr we have, S we have, and O we have. So in all the cases, oxygen is in oxide form, O2 minus. Got it? So we need to find out which one, either chromium or sulfur, which one undergoing reduction, which one undergoing oxidation. This is the thing we need to find out. Now let us see this Cr2O72 minus converted into Cr plus 3. In this case, I need to find out how many number of electron involved. To know that, let us find out what is the oxidation state of Cr here. To find out, what should I do? I have how many Cr? 2 Cr. So let me write 2x plus 7 minus 2 is equal to minus 2. Then what I can next do? So 2x minus 14 is equal to minus 2. Then 2x is equal to minus 2 is minus 14 is brought to the other side, becomes plus 14. Then 2x is equal to plus 12. Then if you want to find out x, what you can do, 12 by 2, it is 6. So here Cr is in plus 6 oxidation state. This plus 6 now converted to plus 3. Look at the oxidation number of Cr. It is decreasing from Cr plus 6 to Cr plus 3. which means that it is undergoing reduction. How it happens? The Cr plus 6 by receiving 3 electrons gets converted to Cr plus 3. Got it? So accepting electron is a reduction. Cr plus 6 is reduced to Cr plus 3. We need to find out which is undergoing oxidation. So let us now take this SO2. In this SO2, I need to find out what is the oxidation state of S. So to find out oxidation state of S, what I am going to do, I have only one S present and then I have two oxides. Oxidation state is -2 and then it is going to be equal to 0 because SO2 is a molecule. Got it? So now if I find out the oxidation state, what I found here is one of the oxidation state of sulfur is +4. Got it? Then in this sulfate ion, SO4 2 minus, SO4 2 minus, in that I am going to find out what is the oxidation state of sulfur. So X plus 4 into -2 is equal to -2. So X minus 8 is equal to -2. X equal to -2 is -8 is brought to the other side, becomes +8. X equal to 6. Now what happens here? Sulfur is in +4 form. Here sulfur is in +6 form. So S 4 plus converted to S plus 6. Now look at the oxidation state. Oxidation state increases. Increase in oxidation state means it is undergoing oxidation. So to form +6 ion, it has to lose 2 electrons. In this reaction, we found which is undergoing oxidation, which is undergoing reduction. Now I'm going to table it. Okay. The first column I'm going to write oxidation half reaction. The next column I'm going to write reduction half reaction. The first step is to balance atoms other than oxygen and hydrogen. So now let us see what are the atoms present here. Here oxygen is there and the sulfur is there. So I have to first balance sulfur. So let me look at how many number of sulfur atom on the left hand side and on the right hand side. I have one sulfur on the left hand side and one sulfur on the right hand side. Sulfur is already balanced. Now let us come to reduction half reaction. In this, as per the first step, we need to see how many number of chromium on the left hand side. Chromium we have 2 on left hand side, whereas on this side I have only one chromium. So to balance this, what should I do? I'm going to introduce number 2 before Cr so that I can balance number of Cr atoms. Well, let us move on to the next step. So now we have balanced atoms other than oxygen and hydrogen. Now we need to balance number of oxygen atom present here. Look at this. On the left hand side, I have only 2 oxygen atoms, whereas on the right hand side, I have 4 oxygen atoms. So I have 2 oxygen atom in short of reactant side. So to balance oxygen atom, I'm going to introduce 2 water molecules. In one water molecule, I have 1 oxygen present. To have 2 oxygen atoms, I need to introduce 2 water molecules. 7 oxygen atom on the left hand side. To balance oxygen atom on the right hand side, I have to introduce 7 water molecules. Got it? The third point is to balance hydrogen atom. When you introduce 2 water molecules on the left hand side, the number of hydrogen atoms here becomes 4. So to balance oxygen atom, we introduce 7 water molecule. Now what we need to do? We need to balance number of hydrogen atoms present. So here we have 14 hydrogen atoms are there. So to balance hydrogen, I have introduced 14 H plus on the left hand side. Got it? So let's move on to the next step. Now we need to balance the charges. How we can do this? Here, since SO2 is a molecule, the charge over it is 0. H2O is also a molecule, the charge is 0. Whereas here, I have -2 charges, and here I have 4 positive charges. Now, on the left hand side, I have the total charge is 0. Then I need to make the right hand side total charge also to be 0. When you add it, so you'll be getting +2. So, but I need to get 0. So I have to use -2 on right hand side. so that plus 2 and minus 2 would become 0. To have minus 2, I'm going to introduce 2 electrons. Clear? So I'm balancing the charges on both sides. Since left hand side I have neutral molecules are there, the net charge is 0. So to balance the charge, I have to introduce 2 electrons because we have on sulfate ion minus 2 charge, on H plus you have, since I have 4 H plus, I have 4 positive charge, the net charge is plus 2. So to have 0 I need to introduce minus 2. I hope you understood. So here you see you have minus 2 charge on the left hand side, and then here we have 14 positive charges. So it would become, I will be having plus 12. Got it? So left hand side I have 12 plus 12 we have. Now come back to the right hand side. 2 threes are. Here I have 2 chromium plus 3 ions. So 2 threes are plus 6. Okay. 2 threes are 6. Now I need to balance this. So I can use only electron. Electron charge is minus. So to have 6, I need to have 6 minus 6. I need to have minus 6 here. So I have to introduce 6 electrons. Students got it? So let me move on to the next one. Now look at the number of electron lost. Number of electron lost here is 2 electron. Here the number of electron needed is 6 electron. So always the number of electron lost should be equal to number of electron gained. To make it equal, I need to multiply the entire equation by 3 so that 3 2s are 6 would come. So I'm going to multiply it. Then here I don't need to do anything. After multiplication, so I will be getting this equation. So how did I get this? So number before here is 1. 3 into 1 is 3. 3 2s are 6. 1 into 3 again 3. 4 into 3 it is 12. 3 2s are 6. Here I'm going to retain the equation as it is. Got it? So now what I need to simply do, I made the number of electron lost is equal to number of electron gained. So I have to simply add it. Let me show here how to add this one. 3SO2 plus 6H2O gives 3SO4 2 minus plus 12H plus 6 electrons. So the next one, Cr2O4 2 minus plus 14H plus 6 electron gives 2Cr plus 3 plus 7H2O. I have just written these two equations here. Then what's the rule? The rule is to add these two equations is to cancel if you have anything in common. If not, you can add everything, whatever it is given on reactant side and whatever it is given on product side. You can add it straight away. So in the first equation, you have 3SO2. So I have written 3SO2 here. What I can have here, I have minus 12H plus equal to 2H plus. So I have here 2H plus. Then we have written all the reactants of both first reaction and second reaction. Then here I have 3SO4 2 minus, I have written it, and then we have written already. Then the second equation I have 2Cr plus 3 and then plus H2. Clear? So because when we bring this term this side, 7H2 minus 6H2 would become only 1H2. That's it. This is how we are going to balance a redox reaction. I hope you understood. Thanks for watching and kindly subscribe and like and comment.